Hey guys, Mr. Starry again. Today I want to talk about graphing standard form. Now, the kind of challenging part about graphing standard form is, unlike slope-intercept form and point-slope form, standard form doesn't really tell us anything. There's nothing I can really look at this and go, oh, that's where I need to start, or there's my slope, or that's an ordered pair that I could use to start my graph. It doesn't tell us anything like that. And what you'll notice is I'm actually going to show you two different ways to graph the same standard form equation. And you can kind of pick what strategy you like, because I like both. So let's jump right in. How do you graph something like this? Well, you could go the old table route, the XY table. You could graph by using the intercepts, or where the standard form line would cross the X and Y intercept. Well, what do you know about intercepts? You know that one of your intercepts, your y-intercept, is when your x value is 0, and your x-intercept is when your y value is 0. So you can draw yourself a little table like this, and literally what we're going to do is we're going to substitute these values in for x and y and see what we get for our missing table parts. So let's do that. Again, I just kind of picked these. This would be how we kind of graph every standard form equation. We'd have a 0 for x, a 0 for y. We're going to substitute and see what we get on the other side. Now, what if my x is 0? So it would be negative 2 times 0 plus 3y equals 6. Now, what's nice is this negative 2 times 0, well, that just becomes 0 plus 3y equals 6. Well, 0 plus 3y, that's kind of unnecessary, so I can just have 3y equals 6. Well, how would I solve for y? Well, this is 3 times y, so I'm going to divide by 3 on both sides and get y equals 2. So when my x value is 0, my y is 2. And that kind of gives me an ordered pair that I can graph. So 0, 2 would be right there on my graph. Now, we would just do the same thing, but this time we're going to substitute for y instead. So negative 2x plus 3 times 0 equals 6. So something similar happens just with our y this time. Negative 2x plus 0 equals 6. Again, we can write that even simpler. Negative 2x equals 6. And now I just have a one-step equation to solve. Negative 2 times x equals 6. So what do I do to solve? I'll divide by negative 2 on both sides and get x equals negative 3. So what that means is, when my y value is 0, x equals negative 3. And this is what we'll need to make our graph. You've just created two ordered pairs that you can draw a line through. And that's enough to make a graph. Well, negative 3, 0, negative 1, 2, 3. Up and down 0 would be right here. You have your two ordered pairs, your 2 points, so you can go ahead and draw yourself a line. And you could graph that way, graphing using intercepts. Another strategy you could use is, one of the fan favorites of graphing equations is slope-intercept form. Could I convert this equation into slope-intercept form and then just graph that? Well, remember, slope-intercept form is y equals mx plus b. So what I'll be trying to do is, I'll be trying to solve this equation for y. Well, let's do it. We'd start by adding 2x to both sides of my equation. And I'd be left with 3y equals 2x plus 6. And what you'll notice is I'm only one step away from solving for y. We'll divide by 3 and divide by 3. Now I'm sorry, I'm going to have to move down here a little bit. So I'll have y equals, well, 2 divided by 3. How can I write that? 2/3 x. Positive 6 divided by 3 is positive 2. So what you'll notice is I just converted this standard form equation into slope-intercept form. Why? Because slope-intercept is probably one of the most straightforward graphing equations that we can kind of look at. Remember, my plus 2 or my positive 2 is my location of my y-intercept. So on my y-axis, my first order pair would be here. And my slope is 2/3, so I need to rise 2 and run 3. Rise, 1, 2, run, 1, 2, 3. Now what you'll notice is, I'm going to go ahead and draw this a while. And what you'll notice is we pretty much have the same exact graph. Now I'm a little off because I'm trying to use a marker here, and my margin for error is a little difficult to kind of cover up here. But essentially what we did is we graphed the same line. And you'll sit here and you'll go, Miss Starry, well, these are two different dots. Remember, when you're graphing, the dots aren't really what matters. The line is what matters. We use the dots to help guide the drawing of the line. So it's okay that these dots are kind of in different spots. And if you would look kind of closely, look at our first one. What was our slope? 1, 2, rise, 1, 2, 3, run. And if I would go 1, 2, rise, and 1, 2, 3, run, I'd have an ordered pair there as well. And just the same over here. Again, this is where you'll see my inaccuracy a little bit. If I would reverse my pattern, down 2, left 3, down 1, 2, left 1, 2, 3. Again, my inaccuracy kind of missed the point there. But I should have a line. These two lines are going to be identical. So we have two strategies when it comes to graphing standard form. We can either use a mini table, or we could solve for y and graph it by using slope-intercept form. You pick the strategy that works best for you, or practice both. Both are good to know, and they're great for your kind of algebraic thinking moving forward. But that's how we graph standard form equations. That's all I have for you today in this one, guys. We'll talk to you in the next one.